What is up, scientists? Today we are going to explore how to predict, observe, and record changes in states of matter. Before we get into it, let's look at our essential questions so we can see what kind of different things we will be exploring today. Now, let's talk about our essential question. Remember, essential questions in science and in different lessons can help us think about what we already know about a topic, and it helps us connect to new ideas that we're going to learn today to help us produce a new thought about the topic. Our essential questions will be focused on our different science topics. So look for keywords. In those keywords, the minute you see them and recognize them, I want you to think, what do I already know about this topic? Once you have that in your mind, you want to look at the question again to see what we're trying to answer today or what are we trying to answer about that topic. It's important to remember that an essential question is like a goal as well. By the end of our science lesson, you should confidently be able to answer the essential question. Let's go over our essential question for today. Since this is a new unit for us, there are new essential questions that we are going to look at and address. Matter, or the foundations of matter, is what we're looking at. And you might be like, what does that mean? Well, what do you think it would be like if we could not describe the things that were around us? Look around. There's so many different things. There's people, there's tables. I feel the air or the wind. I see the wind moving the leaves outside. But what would it be like if we could not describe the things around us? How would we be able to express our scientific ideas and discoveries? Well, we're going to talk about the foundations of matter and learning how scientists actually describe the different things around us, different categories they put us in, and how they describe those specific categories by looking at certain properties of them. But what are our essential questions for these lessons? As we talk about matter, we will focus on these three essential questions. I will read them as they pop up on the screen the first time. Read them the second time with me. The first one is, what are the three states of matter? Read that one with me. What are the three states of matter? Nicely done, scientists. Let's look at the second essential statement we will try and be answering. How does heating cause matter to change state? Say that one with me. How does heating cause matter to change state? Good job, scientists. And our last one. Remember, we're exploring these in today's lesson and for the next couple days as we talk about the foundations or basics of matter. For the last question, it says, how does cooling cause matter to change state? Read that one with me. How does cooling cause matter to change state? Nicely done, scientists. Let's get into a little activity today to get our brains thinking about matter and what types of matter are around us and what does it have to do with anything about heating and cooling. If you look at this picture of fire, what does it make you feel? What do you see when you look at different types of fires? Sometimes I see different colors. I've seen blue fires, red fires, fires that are hot, and fires that are sometimes fake and even warm that you can control. Well, what do these different things do to the states of matter and how are they going to affect what we're learning? Well, let's look a little bit at it with an ice cube today. I got an ice cube from my fridge. You can see it left a little bit of a rim on my napkin already. We're going to see what we can do with this ice cube when we apply some heat. I have a hair dryer here and I'm going to put it on cool and low. Let's see what happens to our ice cube. It's going to get a I switched up the camera angle for you guys so we can get a look at the ice cube a little bit closer. We're using my iPhone here and we're looking at the camera. I still had the hair dryer on a low heat and it was only blowing a little bit. Take some notes about what you notice happening to the ice cube and the napkin around the ice cube. If I'm getting a little impatient though, How could I make this ice cube melt a little bit faster? Oh, I can look at the switches on my hair dryer. I'm gonna bump up the speed a little bit. We're gonna go from warm or from cool to warm and see how that affects the ice cube. Now, sometimes it's hard to see what exactly is happening to our ice cube, so let's slow it down. In this video, I took a slow motion video to show you exactly what's happening to the ice cube when I turned the hairdryer all the way up to hot. So it was blowing the warmest air it could on our ice cube. As a class, I want you to watch this video. At the end of the video, I want you to talk about what are some things you noticed about the ice cube? How did the ice cube change from the beginning of the video when we started? Also, what's happening to our napkin? Our napkin has changed a little bit in our video too. Our ice cube was changing as I added different kinds of heat levels to it. It started off with some cool wind, a little bit of warm wind, and then some hot wind. Now, there's different things that can change an ice cube and make it melt. Today, you guys are going to further explore ways that an ice cube can melt, and you're going to track the exact time of it. Remember, one of our videos was in slow motion, which means we saw it as slow as the ice cube would melt, or we stretch the video out. You guys are going to watch the ice cube closely and make your observations as time goes on for how the ice cube is changing and what different kinds of things you're adding to the ice cube to make it change. Remember our essential questions. We're talking about the 3 states of matter. We'll review more specific vocab on what those 3 states are later, but we're also talking about how cooling and heating affect different items. Focus on those 2 essential questions as you explore today. I'll talk to you later, scientists. See you soon.